Question 4a. A transformer with 1000 turns in its primary coil and 45 turns in its secondary coil is designed to deliver to the secondary circuit an average power of 1100 watt and a maximum voltage of 100 volt. What is the maximum current in the primary coil? So here we have a transformer with 1000 turns in primary coil. So I can write NP to be equal to 1000. The number of turns in secondary is 45. The maximum secondary voltage Vs is 100 volt, whereas the power average across the secondary is 1100 watt. We need to find the maximum current in the primary circuit. Now, how do we get average power? Average power is half of the maximum power. And for a transformer, we know that power across secondary is equal to power across the primary circuit. So I can use the same expression for power to calculate the primary current. But how do we relate average power to primary maximum current? So average power can also be written as a product of Vrms to Irms, because power itself can be written as product of V into I. When it is maximum power, it is product of maximum voltage with maximum current. And for average power, it is Vrms times the Irms. Now what is Vrms? Vrms is 0.707 times the maximum voltage. Or you can also write this as Vmax over root 2. Same goes for Irms. So I can rewrite this expression as Vmax over root 2 times Imax over root 2. And when you multiply them together, you get the same expression back. Vmax times Imax is nothing but the maximum power. And root 2 times root 2 will give you 2. So here I'm going to use this expression for average power to calculate what will be my maximum current in the primary. We are going to replace this with primary voltage and primary current and rearrange the term to write in terms of current I. So we rewrite this expression, power average times root 2 into root 2 will be 2, divide by Vmax. Vmax I will take for the voltage across primary, so Vp is equal to Ip. So this is the expression for maximum current across the primary. But to find this current, I need to find what is the voltage across the primary, the maximum voltage across the primary. We're going to use the transformer equation to find Vp and then return back to this expression. So we know from transformer equation, Np over Ns is equal to Vp over Vs. You can also flip this ratio. It will not change your final answer. Potential difference across the circuit is directly proportional to the number of turns. So as long as P remains with P and S remains with S, no matter in what manner you write this expression, it's going to give you correct answer. So let's rearrange. I get Vp to be equal to Np Vs over Ns. You can also use shift solve here to find Vp. Np is 1000, Vs is 100, Ns is 45. That gives me Vp to be equal to 2222.2 volt. Now let's use this to find the maximum current across primary. Ip is 2 times power average over Vp. So 2 times 1100 over Vp, which is 2222.2. That gives me maximum current across primary to be equal to 0.99 ampere. So while solving this problem, this is the expression that you must remember, the relationship between average power and maximum power. And then after using transformer equation, you can arrive at the maximum current across primary. Then let's discuss question 4b, which is similar to 4a. Here again, you have a transformer with 1000 turns in primary coil, 50 turns in secondary coil, It is designed to deliver to the secondary an average power of 1100 watt with a maximum voltage of 135 volt, and we need to find the maximum current. So again, NP is 1000 turns, NS is 50 turns, power average is 1100 watt, maximum voltage across secondary is 135 volt. We need to find maximum current across the primary. So let's start with the expression for power again. We know the average power is half of maximum power. Maximum power you can write as maximum voltage across primary into maximum current across primary over 2. And we can relate this to primary voltage and current because power across secondary will be equal to power across primary for a transformer. Now let's rearrange. I get IP to be equal to 2 times power average over VP. Call this equation 1 because we still need to find what is VP. We will use transformer equation to find this. So we write NP over NS is equal to VP over VS. So VP will become equal to NPVS over NS. Again, you can use shift solve directly over here to find VP. NP is 1000, VS is 135, and S is 50. That gives you VP to be equal to 2700 volt. Now use this in equation 1. I get IP as 2 times power average over VP, which is 2 times 1100 over 2700. That gives me IP to be equal to 0.815 ampere.